Gravitational force. People have known since ancient times that the Earth is a sphere and objects that are near the surface tend to fall down. Newton connected the idea that objects, like apples, fall towards the center of the Earth with the idea that the Moon orbits around the Earth. It is also falling towards the center of the Earth. The Moon just stays in circular motion since it has a velocity perpendicular to its acceleration. Newton concluded that all objects attract one another with a gravitational force. The magnitude of the gravitational force decreases as the centers of the masses increases in distance, meaning that as objects get further away from each other, there is less gravitational attraction. Mathematically, the magnitude of the gravitational force is proportional to the masses of the objects and inversely proportional to the square of the distance between the two objects. So the gravitational force is equal to capital G times m1 times m2 divided by r squared. Now that capital G is what we call the gravitational constant. In 1798, a man named Henry Cavendish measured G using a torsion beam balance. He did not initially set out to measure G, he was instead trying to measure the density of the Earth. He found that G equals 6.67 times 10 to the negative 11th. The direction of the force is along the line connecting the centers of the two masses. Each mass feels a force of attraction towards the other mass along that line. Newton's third law tells us that the force on each mass is equal. That means that if I drop a pen, the force of the Earth pulling the pen down is equal to the force of the pen pulling the Earth up. However, since the mass of the Earth is so much larger, that force causes the pen to accelerate down while the movement of the Earth is completely unmeasurable.